The Internet and the World Wide Web are not the same thing, and this is a guaranteed exam question because almost everybody uses the words interchangeably. The Internet is the global network of interconnected computer networks. It is infrastructure, cables, fiber, routers, satellites, and the protocols that let them all talk. It is the roads. The World Wide Web is a collection of websites and web pages that are accessed using the Internet. It is one of the things that travels on those roads. And the way to see that they are genuinely different is to notice what else uses the Internet without being the web. Email, video calls, online games, file transfers, streaming, all of those use the Internet, and none of them is the World Wide Web. So the Internet is hardware and protocols. The web is content accessed over it. If a question asks you to distinguish them, the word to reach for is infrastructure against content, and giving a non-web example of Internet use proves you understand it rather than remembering it. Now the protocols that carry web pages. HTTP is the Hypertext Transfer Protocol, the set of rules for transferring web pages between a server and a browser. And with plain HTTP, data is sent as plain text. HTTPS is the same protocol with security added, and the S is exactly that, secure. Data is encrypted before transmission, and here the encryption from topic 2.3 earns its place. When you connect to an HTTPS site, the site sends its digital certificate, the browser checks it, and the two agree on encryption keys. Anyone intercepting the traffic afterwards captures ciphertext they cannot read, which is precisely the promise we established in 2.3. It does not stop interception. It makes the intercepted data meaningless. So the padlock in the address bar means the connection is encrypted. Note carefully what it does not mean. It does not mean the site is honest or safe. A fraudulent site can obtain a certificate and use HTTPS. The padlock tells you nobody can eavesdrop on your conversation with that site. It says nothing about who you are talking to. SSL and TLS are the protocols doing that encrypting. SSL, Secure Sockets Layer, is the older one. TLS, Transport Layer Security, replaced it and is what is actually used today, although the name SSL persists in conversation. The syllabus wants the handshake in outline. The browser requests a secure connection. The server sends its digital certificate, which contains the server's public key and is signed by a certificate authority, a trusted third-party vouching that the server is who it claims to be. The browser verifies that certificate. If it is valid, the two agree session keys, and from that point, everything is encrypted. Notice the shape of that. Asymmetric encryption is used to establish the connection and exchange keys safely, and then symmetric encryption handles the actual data because it is faster. That is the hybrid arrangement mentioned at the end of the encryption lesson, and this is where it is really used. Every secure page you load. Let us put this together with the thing you do 100 times a day. You type an address and press enter. What actually happens? First, the browser needs an IP address because that is what packets are routed to, and you typed a name. Second, it sends the domain name to a DNS server. DNS is the domain name system, and its job is exactly this translation. It is often described as the phone book of the Internet, holding a database matching human-readable domain names to machine-readable IP addresses. Third, the DNS server looks up the name and returns the corresponding IP address, and if it does not hold that domain itself, it asks another DNS server further up the hierarchy. Fourth, the browser now has an IP address, so it sends an HTTP or HTTPS request to that address. If it is HTTPS, the TLS handshake happens here. Fifth, the web server receives the request and returns the page, the HTML, and then the images, style sheets, and scripts it references. And sixth, the browser renders all that into what you see. So why does DNS exist at all? Because remembering names is easy, and remembering numbers is not. And because a site can change servers and therefore change its IP address without anybody having to learn a new address, the name stays, only the DNS record changes. A URL, a Uniform Resource Locator, is the full address of a resource on the web, and it has name parts the syllabus expects you to identify. Take a typical one. The protocol comes first, HTTPS, followed by the colon and double slash, then the domain name, which is the name of the web server, and which itself has parts, the second-level domain, and the top-level domain such as .com or .org or a country code. Then, after a slash, the file path, the folders and file name identifying the specific page on that server. So a URL answers 3 questions in order: how to talk to it, which server to talk to, and which resource on that server to ask for. If a question shows you a URL and asks you to label the parts, that is the structure being tested, and knowing the order means you can label one you have never seen. Finally, the browser itself, which is the software that lets you access and display web pages. Its named features are worth listing precisely because a question asking for browser functions expects several. It stores bookmarks and favorites. It records user history. It allows multiple tabs to be open at once. It stores cookies, which is the next lesson. It provides navigation tools: back, forward, refresh, a home button. It has an address bar for entering URLs. It manages downloads. And underneath all of that, its central job is one you never see. It reads HTML, CSS, and JavaScript sent by the server and renders them into the page on your screen. That is the thing a browser fundamentally is, an interpreter for web documents. Everything else is convenience around it. 4 things to take into the exam. First, the Internet is the global network infrastructure. The World Wide Web is the collection of web pages accessed using it. Give a non-web example of Internet use. Email is the easiest to show you have the distinction rather than the phrase. Second, HTTPS is HTTP with encryption using SSL or TLS, and the padlock means the connection is encrypted, not that the site is trustworthy. Third, DNS translates domain names into IP addresses, and if you can say why, names are memorable, and a site can change its IP address without changing its name, that is stronger than reciting the definition. And fourth, when labeling a URL, name the parts in order: protocol, domain name, file path. Those are the terms the mark scheme uses.